midpoints. Anytime we have in this video, we should be able to find the midpoint of a segment on and off the coordinate plane. Okay, so what is a midpoint? Well, the midpoint of segment AB is the point M on AB with AM equal to MB. The tick marks are used on the figure to show equal segments. Okay, so in this situation, AM and MB would be the same length. So let's start with an example. Suppose that AM is 6. Well, if AM is 6, and M is the midpoint, that's what we're assuming for this entire slideshow, then AM is equal to MB. So if AM is 6, then BM is 6, and AB, the entire segment, is 6 plus 6, or 12. Well, suppose we have different information. Again, we are still assuming that M is the midpoint of segment AB. But this time we're told that the entire segment is 42. Well, if the entire segment is 42 and these parts are equal, then each one is half of the whole. So AM is 42 divided by 2, which is 21. And if AM is 21, then MB is also, let's try that again. If AM is 21, MB is also going to be 21. Some variables involved. Okay, well, suppose this time we know that AM, I'm going to put my tick marks to show that they're equal, that AM is 6x plus 4, and MB is 8x minus 10. Well, since we have a midpoint, we know that these two expressions are equal. Okay, our goal, though, to find AM, BM, and AB is to come up with numerical values. So we need to do out the algebra. Okay, so if 6x plus 4 is equal to 8x minus 10, okay, then we need to solve for x. So we subtract 6x from both sides, and we're left with 4 is equal to 2x minus 10. Add 10 to both sides, and we're left with 2x equals 14. Divide both sides by 2, and x is 7. Okay, so if x is 7, and we want AM, we need to substitute 7 in for x. So 6 times 7 plus 4. Well, 6 times 7 is 42, plus 4 is 46. Okay, same thing with BM. 8 times 7 minus 10. Well, 8 times 7 is 56. Minus 10 is 46. Okay, well, this is like wee doggy. We want them to be equal, and they are. That's a good thing. So to find AB, we're going to add them together. 46 plus 46 gives us 92. Okay, let's try another one. It looks like this formula is a little bit off. The plus sign goes there. Okay, so to find midpoints on the coordinate plane. Okay, so when we're graphing, we have 2 points, x1, y1, x2, y2. Okay, and we want the midpoint of that segment. Well, the way we do this is we find the average x and the average y. So we add our 2 x values together and divide by 2. We add our 2 y values together and divide by 2. Okay, so let's try an example. So here's our segment. 6, negative 5, 18, negative 12. Okay, if we were to graph these on the coordinate plane, Okay, we would be at the point 6, -5, and 18, -12. Our segment would look something like this. Okay, so we know just by looking at it, our midpoint should be somewhere around here. So we're going to use our formula. We're going to label our points x1, y1, x2, y2. Okay. And we're going to plug in. So m for the midpoint is going to equal, that's not slope, that's midpoint, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Again, the average x and the average y. So we add 6 plus 18, we get 24 divided by 2. -5 plus -12 is -17 divided by 2. Okay, 24 divided by 2 is 12, and -17 divided by 2 is -8.5. So here's our midpoint, 12, -8.5. And there's one more important thing you need to know about midpoint. Sometimes you have points that are the same distance from the endpoints of a segment that are equidistant from each point, but not a midpoint. So when you have 2 points that are the same distance away from the endpoints, they're called equidistant, equal distances, but unless they're on the actual segment, they're not midpoints. Okay, good luck with the your turn problems.